Welcome to the sixth episode of Season 3 on the Tech Innovator podcast series, proudly presented by the IEEE Tech West Sri Lanka. Today, we venture into the cutting edge of innovation, exploring the fascinating claims of neurorobotics and artificial intelligence. I'm your host, Sakunika Dituakku, and today we have Dr. Sunit Patirana, a senior lecturer and a researcher in brain-machine interface in artificial intelligence and robotics. Also, Dr. Patirana is a specialist in neurorobotics, holding a PhD in neurorobotics from the MSU Malaysia, MSc in artificial intelligence from the University of Moratuwa, and BSc Honors in computer science and technology from Uwawellas University of Sri Lanka, and also he is a member of IEEE and the advisor of IEEE Computer Society chapter in IEEE Uwawellas University student branch. Hello, Dr. Patirana. It's truly honored to have you with us today.
Okay, welcome.
Now, as we delve into the intersection of neurorobotics and artificial intelligence, we unreveal the potential impact on the future landscape of human-machine collaboration. The evolving synergy between these cutting-edge fields is poised to reshape our interactions with technology. Join us as we focus on the transformative changes expected in daily life, industries, and the broader technological spectrum. What lies ahead as neurorobotic and artificial intelligence coverage? This fundamental reflection guides our exploration today, with Dr. Sunit Patirana guiding us through this integrated journey. Dr. Patirana, in your expertise and your background in brain-machine interfacing, how do you see the intersection of neurorobotics and artificial intelligence shaping the future landscape of human-machine interactions? Over to you, sir.
Okay, I think you are aware of these recent innovation or the experiment conducted by Elon Musk. So the Neuralink project. So it attempts to implant kind of a brain chip inside the head of human. Actually, he's targeting the disabled people, but it's beneficial for not only for the what we call the disabled or the paralyzed people that will be beneficial for the all humankind in near future. So if we take an example how this relates to other disciplines, the development or the advancement of the other scientific research arena. So I will continue on the same example. So this is regarding the reading the brain or recognizing the intentions of the human. So reflected through the electrical activity of the human brain. So although this is kind of human, what we call brain-machine interfacing or brain-computer interface, but uh, that what we call that contributes significantly for the advancement of the other developments such as machine learning, neuroscience, cognitive science, and human-computer interaction, and finally for the neural computing and signal processing kind of disciplines, because you need machine learning, AI machine learning algorithms in order to classify these brain signals, or what we call these EEG, in electroencephalographic signals. To classify them in real time, you need to apply AI machine learning algorithms, and this can be connected to so many other devices such as bionic eyes, or what we call the other. This can manipulate the decisions made through these what we call these impressive technology can be connected to other organs such as the prosthetic arms or the augmented reality AR glasses, wearable glasses, or the contact glasses. And finally this will end up with these mind uploading, what we call, you might have heard about these whole brain emulation or kind of artificial life. That means you can simulate the human life or make a clone of your conscious, so your cognitive what we call the not the behavior can make your conscious things, what we call, in you can it can be run on a computer. So it's related to almost all the disciplines, including the biosignal processing, brain fingerprinting, AI machine learning, augmented reality, neuroscience, cognitive science, like that. That's how these neuro and the people who are suffering from lack of that means damage happened to their natural organs, or what we call the we are going to replace the damaged limbs, such as hands or legs, with these prosthetic arms. So, and we can manipulate wheelchairs kind of things, even the vehicles in the near future. The Nissan is doing kind of research involving, and the Meta, like giant people are investing billions of dollars on these research on these neurorobotics and brain machine interfacing. So that's it, how it is contributing for the advancement of the other related discipline that has applications in almost all the research arenas, and a vast that has a very broad spectrum of coverage, addressing or covering applications in almost all consumer grade and medical grade and industrial applications. So many applications in almost all the application areas. I think I did reply for you.
Yes, sir.
Did I answer? Okay.
With your answer, I would like to know, in what ways can neurorobotics enhance our understanding of human brain, and how might this knowledge be applied to advanced artificial intelligence?
So as I already emphasized, so these really directly that means provide fertilizers, or the what we call the these directly contributes for the what we call the cognitive science. So some universities like Carnegie Mellon universities are expertised in these areas. So cognitive science is a kind of attempt of understanding the how the brain functions, so how the cognitive higher level cognitive tasks are being executed, to try to kind of a multidisciplinary research area that tries to understand the human psychological and physiological neurological behavior. So while facilitating or providing what we call catalyst for these cognitive science, which relates to almost all the philosophical and AI related disciplines in on like the how knowledge can be represented. That means ontological engineering and other things, and we need again machine learning kind of things, and kind of biosignal processing. So everything is related. So I see the highest what we call the strongest bridge that has the neurorobotics or the brain machine interface has constructed is between the cognitive science and the what we call the human brain. So once we resolve the burn that we call the inquisitive, what we call the once we develop the understandings coming under these cognitive science, I think it's done. That's how it relates to other that means cognitive science is related to all these almost all these psychology, physiology, and philosophy, all these other branches of study. So that covers a wide spectrum. So I think is it okay, the question? Are you satisfied with that?
Yes, sir.
Okay.
I think it's okay. Yeah. Thank you, sir. Let's move on the next question. How can we ethically navigate the advancement of interconnected AI and neurorobotics? What risks accompany the convergence of these technologies, and how can responsible development ensure the safety and well-being of individuals?
Okay, there can be certain vulnerable points, or the certain ethical risk, or kind of ethical issues derived through this implementation. For example, so if these neural links, this brain chip, if that has access to that, if that connects to kind of a wireless network or kind of internet, That means the human will become an Internet of Things IoT device one day. So then think about the privacy and the confidentiality of the data. So our brain will provide data. If somebody can exploit those data, probably then we need to properly define who are the parties, third parties, going to access this data. For an example, so our eye. So if we have a kind of a eye, so bionic eye kind of a thing, so that can be utilized as kind of evidence collection. For an example, if the government agencies are authorized, like the criminal investigation department, so they are given authority to access our memory and the what we have seen through our eyesight, as say they want to inspect kind of investigate on a crime kind of thing. If we have eyewitness, so they try to access our brain like that. That's only an example. So who is going to hold the responsibility, who will be given the authority to access our confidential data? That is one thing. And other thing is, so if another malicious party got access to our brain chip, then what will happen? They will steal our data confidential, even our maybe that is connected to our all other the financial, or we call the bank accounts and other things, and that will steal our confidential data and reveal or sell that to somebody with malicious intention. Or even people can manipulate the things that are connected. For example, our if we are wearing kind of a AR, augmented reality enabled contact lens. So some fabricated scenes or the fake evidences can be created. So somebody can manipulate someone. They can influence us to doing unnecessary things. So sometimes they will make fear. For an example, there can be some fabricated misguiding scenes can be uh, shown on these bionic contact, or especially for post advertising. So if we don't want to buy something, so they can keep without your intention or without your request, they will try to, if somebody get the grant the access, the unauthorized people get access to your brain chip wirelessly. They will show some advertisements, and they try to influence to you to buy something. They are insisting you to buy like that. That means till you buy, they will not stop like that. Who is going to hold these kind of scenarios? Does the government take the responsibility of restricting access to these public profiles, or the individual profiles? And who is going to, that is very so much dangerous. For an example, say one person lives on kind of in developed countries, they use these artificial hearts, not heart part of that, means kind of a pattern, or the what we call the pulse maker, we call phaser. So pacemaker. So some people, their heart is running on the impulses, or what we call the pulses generated through these kind of electronic device phases. So if somebody try acquire what we call capture your unauthorized person capture your brain chip, probably they have access to these what we call control or to manipulate these kind of peripherals. Okay, then the persons, so we can artificially, that means increase, change the heart rate pattern pulses. So that is so dangerous. Like that, there are so much advantages like health. That means so the neurorobotics, so these modeling attempts to derive kind of models for the to investigate these neurological disorders. We can discuss on a later topic. But there's a significant notion of risk involved, and ethical and privacy issues will be there. Data consistency issues will be there. Data tampering and uh, things related to data information security and information sharing, access control, the other protocol issues, those things will be there. I think, did I cover your question?
Yes, sir. I hope next questions also it's similar to how to save. when using personal AI tools, how do we find the right balance between the helpful benefits and making sure our private information stays safe? I hope you have answered questions as well.
No, I can add something. So we
Yes.
have to use the precautions or the other what we call the other prevention technologies to get rid of these vulnerabilities that we are usually practicing in cybersecurity, such as encryptions or digital certificates. So the trust policy, that means we have to keep isolated quarantined unauthorized connecting unauthorized devices such as the Wi-Fi routers or IoT devices. So we can follow the usual the strategies that we follow in cybersecurity. So and we have to use the secure gateways, and we have to preserve these credentials, kind of brain fingerprinting. We should not share the what we call the login credentials. Only the government authorized party should be allowed to access whenever necessary. Only like that we can follow these protocols that we usually practice in ensuring the cyber security. Okay, that's it. Okay.
Okay, sir. It's great to hear. Move towards and medical applications, particularly in areas like prosthetic and neurogenerative diseases. How do you see neurorobotics contributing to the improvement of medical treatments?
Actually, the neurorobotics, so they have significant branch of knowledge in neuroscience and neurological disorders. So for an example, so recently, researchers have derived, constructed models, neurological neurorobotic models for the certain neurological disorders. For an example, the Parkinson's disease or Huntington's disease, we call HD, and obsessive compulsive disorder OCD, unilateral partial neglect, and so many other like schizophrenia and ASD, the autism spectrum disorder. Like that, that means the researchers have constructed kind of models, neurological models, neurological models for to simulate and understand or investigate or perform in-depth study of these how these brain functions, how these abnormalities can be detected, how the brain neurons are interacting, like that. In addition to that, there's a separate disciplines called coming under neurorobotics called neuromodulation. So it's a kind of kind of a physiological process of that gives how the neuron kind of the neurochemicals or biochemicals, how they are what is the impact of them, how the stimulations are happening, like that. There are certain other disciplines like neuroimmunity and so many medical applications. In addition to these control of these prosthetic counts, also these what we call the augmentation of human performance, and what we call the haptics, or the what we call the human performance modification, and so many things are there. Actually, these what we call the neurorobotic, so the what we call the neurological models, neurorobotic models for the what we call these to simulate these the brain abnormalities, that is significant. And in addition to that, we have certain research arenas coming, subdisciplines coming under neurorobotics called RAM, restoring active memory. Actually, what is meant by this restoring active memory is that kind of implementing kind of an implantable device that can electrically simulate the brain, kind of a brain simulation to assist improving the brain memory function, to enhance the memory, not the capacity, the how the efficiency of the memory related functions, especially associated with brain. And in addition to that, we have these subnets called a system based neurotechnology for emerging therapies. So it's another research arena, the subnets. And so many things are there like neuro modulation. For an example, researchers have developed an model to understand these anxieties like situations, abnormal mental stimulus or neuro odometry kind of things are there, and neuroimmunity kind of things are there. So many that means this directly benefits the kind of medical treatments and not only that the kind of rehabilitation robotics. So for an example, somebody get damaged or partially damaged organs. So you know the duty of kind of physiotherapist. Okay, so some robotics applications can assist to rapidly recovery or do some exercises, assist to do some exercises to get fast recovery from that broken organs, or let's say one's leg is broken, so he's getting recovered. So the neurorobotics applications we call the rehabilitation robotics can assist to fast recovery from that scenario. In addition to that, so many medical related things are there like embodied cognition, that means again relates to cognitive science, and there are so many links to the medical applications or the disease understanding, the even treatment designing, and some models try to explain, for an example, these human brain project. So the neurorobotic platforms. So these tries to understand how the brain and the physical organs are synchronized, working together. How these the brain generated signals are being synchronized to manipulate these the what we call these human organs. How the response delays are, why the response delays are happening, and how to collect the sensory data through the neural that means the central nervous system and the other nerves, and how the brain responds or what are delays incurred, and how to resolve these issues, response delays and other things. How especially that tries to these like e-brains, like human brain project or the neurological platforms, they try to understand how the brain and the other physical body parts are synchronized to working together. So that will try to resolve some abnormal scenarios or try to improve the efficiency. For an example, this can be directly related to these what we call the Nissan's what we call the brain to vehicle B2V technology. That means how the drivers can better respond to, and how the vehicle can better understand the behavior or the responses from by the driver. So like that, not only the medical applications, so these relates to other industrial applications like automobile technology as well. Anyhow, you have large opportunities, huge opportunities in the research related to medical research and neuroscience and cognitive science related research. In addition to these, what we call these medical applications, such as direct medical applications, such as neuroprosthetics. So I think that's satisfactory. Okay, the answer.
Yes, sir. It's really valuable for our audience, I hope. And it's exciting to consider this advancement. Finally, with your varied background, how do you anticipate the job market evolving with the growing influence of AI and neurorobotics? What transformation might occur in terms of opportunities and advancement for individuals and industries? I hope there was already, you have mentioned in the previous sections, there was opportunity in research areas as well.
So in addition to research, also the giant companies like Meta, these who is the powered the backbone of the Facebook and Nissan, like automobile companies and medical experts, and Tesla. Elon Musk is from Tesla, and Google. Giant companies are spending or investing billions of dollars not only for the research to enable the even the disabled people to interact with the social media and get their support or provide their kind of satisfaction or kind of to access to the social media and other things. So definitely their family members will be willing to invest on these kind of applications. And there are, in addition to these medical applications and research and these new prosthetics and other things. So in other research arenas like other industrial applications such as social media and automobile industry, transportation, there are so many wide opportunities. And the emergence of ChatGPT has changed the this kind of a paradigm shift for the industry. So near future, the traditional software developers or the programmers, their duty will be replaced by these AI programs. They are the generative AI, but we have to very carefully tackle these things. That will not take your expertise jobs, but kind of traditional jobs like computer programming will be replaced. So that's why you need to learn these data science, what we call these bioinformatics, and these information security, AI, robotics, neurorobotics, Internet of Things. So the whole world cities will be converted into smart cities. In that, the so many sensory networks will be there. So many analytical algorithm, real time analysis using machine learning, and will be there. Therefore, in order to secure your job, that means the job demand, to cater the job demand, I don't think the traditional programming knowledge or the web development, that is okay for the survival. Database connectivity, that kind of thing, just okay for the survival as a software or what we call industrial kind of a person. But in the future is with data science, robotics, neurorobotics is coming under that. Data science, artificial intelligence of things, AIoT, like that. Therefore, I think better you consider bridging the gap between these the traditional knowledge of form of knowledge in the software development and other things. I think most of the audience are coming from the representing the computing and IT. That's why I want to pass this message.
Thank you, sir. We had a great discussion with you, Dr. Patirana. So, would we love to know your perspective on IEEE Tech Sri Lanka?
Okay, you are significantly contributing for the advancement of the science and technological knowledge. So that we call the uplift that means you are kind of doing implanting the enthusiasm among the young professionals or the young students. So that's a very fascinating thing. So we should appreciate that this kind of a voluntary thing. No, so it's so spending your time and dedication while doing studies. That's great, I think.
Thank you, sir. We are come to the end. Thank you, Dr. Sunit Patirana, for sharing your expertise with us today and contributing to making our audience more aware of the integrate intersections of neurorobotics and artificial intelligence. So, listeners, hope you all enjoy, and if you are interested in learning more about latest cutting edge technologies, stay tuned with us through our podcast platforms Spotify, Apple Podcasts, Google Podcast, SoundCloud, and Radio Public, and also YouTube, as we have many more sessions lined up for you. Until next time, I'm Sakuni Kodituaku from IEEE Tech Sri Lanka, signing off from this episode. Stay curious, stay tuned for more explorations into the ever-evolving world of technology. Goodbye.